We'll start in 1 minute. Today we'll start section 7.5. This is the section on solving applications with rational expressions. Okay, so for each of these problems, we'll set up an equation, and then we'll solve the equation, and then afterwards summarize the results. In this first one, it says doctors prescribe 13 milligrams of medicine for every 9 pounds of a child's weight. Find the amount of medicine for a child that weighs 54 pounds. This problem is simple enough to just think about it and you can figure it out, but one of the goals is to learn how to set up an equation based upon the information given. So this particular problem involves a proportion. A proportion is an equation with two ratios. So we could say 13 milligrams of medicine is to 9 pounds of a child's weight, as a certain amount of medicine is to a child that weighs 54 pounds. Okay, so let's assign a variable for what we want to find. We want to find the amount of medicine for a child that weighs 54 pounds. So let X be the number of milligrams of medicine. For the 54-pound child. Okay, so we can write the proportion in words. We can write 13 milligrams is to 9 pounds as X milligrams is to 54 pounds. So as I was saying, this is an example of a proportion. But we can translate this into an equation. And in the equation, we'll just use the numbers and the variable X without the units, milligrams and pounds. So we can say 13 is to 9. 13 is to 9 as X is to 54. Okay, and that's all there is to it. Now all we have to do is solve for X. So we could just multiply both sides by 54. So multiply both sides by 54. So 54 over 1 times 13 over 9 equals 54 over 1 times x over 54. Okay, the hard way to proceed is, well, it's not hard since you have a calculator available, but you can multiply 54 times 13 and then divide it by 9. Or you can notice that 9 goes into 54 6 times. So 9 goes into 9 once, and 9 goes into 54 6 times. So now we just have 6 times 13 equals x, or 78 equals x. Okay, to summarize the results, we would just say, we could just write a child that weighs 54 pounds will have a dose of medicine that is 78 milligrams, or something like that. Okay, the next problem, number 2. This one says, Jillian ran 12 miles from her house to the county line, and she got a ride on the return. It took 2 hours longer to run 12 miles than to ride 12 miles. And her run rate was 25 miles per hour slower than her ride rate. Find Jillian's run rate. Okay, this is a uniform motion problem. So uniform motion involves distance equals rate times time. So we want to find Jillian's run rate. So we'll assign a variable for the run rate. I'll pick x to represent Jillian's run rate in miles per hour. And then the ride rate, how do we represent the ride rate?
X minus 2. X minus 2.
So the rates are measured in miles per hour. So what does the problem tell us about the relationship between the run rate and the ride rate? Okay, so part of what we're learning how to do is to pick out the information that's given. And we want to make sure that we don't assign certain quantities to other quantities that represent something different. Well, the very last sentence says find Jillian's rate. So that's why I picked a variable to represent Jillian's run rate. But what information is given about the ride rate? as it relates to the run rate.
miles per hour slower.
Yeah, in the third sentence, it says her run rate was 25 miles per hour slower than her ride rate. So if the run rate is X miles per hour, how do we represent the ride rate?
X plus 25.
Yeah, X plus 25 miles per hour. Okay, and we can check to make sure that makes sense. X plus 25 is 25 more than X. Or we could say X is 25 less than X plus 25. So that appears to be a satisfactory variable representation for the run rate and the ride rate. It's not the only way that we can represent the run rate and the ride rate, but this is good enough. Okay, so now what? So what other kind of information is given?
How many miles she went?
Yeah, how many, the distance in miles that she ran, and also the distance in miles that she rode, because she ran a distance of 12 miles to the county line, and then she got a ride back, which was also a distance of 12 miles. Okay, so we're going to write down two equations. Each of them will have the form rate times time equals distance. One of the equations will represent Jillian running to the county line. So rate times time equals distance running to the county line. The other equation, rate times time equals distance, will represent the return ride of a distance of 12 miles. Okay, so I'll write run equation and ride equation. Okay, so when Jillian was running, her rate is X miles per hour. For now, I'll represent the amount of time it took as T sub run, and the distance is 12 miles. So this represents rate times time equals 12. This represents, or this equation is the model for her running to the county line. And then on the return, when she rode back home, the riding rate was X plus 25 miles per hour. And for now, I'll use T sub ride to represent the amount of time it took to ride back a distance of 12 miles. Okay, the goal is to determine what the value of X is. And can you pick out a key bit of information that we're going to need in the next part?
It took 2 hours longer to run than to ride.
Yeah, in the second sentence, we're told how the times are related. It took 2 hours longer to run 12 miles than to ride 12 miles. So T sub run, that represents the amount of time it took her to run 12 miles. So T sub run is greater than T sub ride by 2 hours. Okay, so we're getting there. The goal is to determine the value of x. So what we want is an equation whose only variable is x. And we can get that equation in a couple of more steps. Maybe 3 steps. So any suggestions? We want an equation whose only variable is x. So we want an equation that doesn't have the variable t in it. Okay, I'll give you a hint. This inequality, the amount of time it took her to run 12 miles is greater than the amount of time it took her to ride 12 miles by 2 hours. We can translate this into an equation. And then for each of the other 2 equations, for the run equation, we can solve for the time, T sub run, we can solve for T sub run. And for the ride equation, we can solve for the time. And then once we've done that, we can substitute into the equation that we formulate over here. And then we'll have an equation whose only variable is x. Okay, so how would I convert this statement here into an equation? T sub run is a bigger number than T sub ride, and we know that it's bigger by 2. So how can I convert this into an equation? There are actually 4 options, but we just want one of the options. 4 equivalent options, but one will be enough. Now let's do something that's sort of similar. You'll agree that 15 is greater than 13 by 2. How can I convert that into an equation? So I'm looking for an equation.
15 minus 3.
Yeah, one way to do it, subtract the smaller number from the larger number. Yeah, 15 minus 13 equals 2, right? And then there are three other options, but so we can do that here. T sub run is a bigger number than T sub ride, and it's bigger by 2. So T sub run, the bigger number minus the smaller number, T sub ride, is equal to 2. Okay, now what? We want to replace T sub run with something that's equal to T sub run. So now we focus on this equation. X times T sub run equals 12. So if I divide both sides by X, I get T sub run equals 12 divided by X, right? And then we're going to solve the other equation for T sub ride. X plus 25 times T sub ride equals 12. So if we divide both sides by X plus 12, we get T sub ride. Do you see how this is working out? Okay, so in the next step, we'll get our equation whose only variable is X. So in this equation, we're going to replace T sub run with 12 over X. And then we're going to subtract T sub ride, but we're going to replace that with 12 over X plus 25. And it's equal to 2. So finally, we have an equation whose only variable is X. X represents Jillian's run rate. Yesterday, we discussed ways to solve equations with rational expressions. So we want to find the least common multiple of the denominators, or the least common denominator. So the least common denominator is X times the binomial X plus 25. And 2 is 2 over 1. So even though we normally don't write it, the denominator is 1. Okay, the next step is to multiply every term on both sides by the least common denominator. So we multiply X times X plus 25 over 1 times 12 over X, and then minus X times X plus 25 over 1 times 12 over X plus 25. And we also multiply the right-hand side of the equation by X times X plus 25. Okay, when we multiply every term on both sides of an equation by the least common denominator, we clear the denominators. So in this first product, X divided by X equals 1. So the denominator is reduced to a factor of 1. In the next product, X plus 25 divided by X plus 25 cancels. On the right-hand side, we don't get a cancellation because the denominator is already 1. Okay, so let's write down what we have we have x plus 25 times 12 minus x times 12, or just minus 12x. And on the right-hand side, we have 2x times x plus 25, which is 2x to the second plus 50x. Okay, x plus 25 times 12 is 12x plus 300, and then minus 12x equals 2x squared plus 50x. On the left-hand side, the 12x minus 12x is 0, and then we have 300 equals 2x squared plus 50x. So we're going to end up solving this equation by factoring. So first we'll subtract 300 from both sides. And I'll write it as 2x to the second plus 50x minus 300 equals 0. Notice every term in the trinomial has a common factor of 2. And since we are solving an equation, we can divide out that common factor of 2. So when we divide every term on both sides of the equation by 2, we get x squared plus 25x minus 150 equals 0. 0 divided by 2 is 0. Okay, it's not too hard to find the factors of x squared plus 25x minus 150. Do you see what those two factors are? Well, we know that the two binomials, they each have to have x. Since we have x squared plus 25x minus 150, we know that one of the binomials has to have a plus sign and the other one has to have a minus sign. Now we just need to find the numbers. So using the AC method, 1 times negative 150 is negative 150. Find two integers that have a product of negative 150 and a sum of 25. Okay, if the product is negative and the sum is positive, the one with the largest absolute value has to be positive. So we can do the systematic approach, negative 1 times 150, negative 2 times 75, negative 3 times 50, negative 4 is not a factor, negative 5 times 30. So negative 5 and 30 are the two integers. So what does that mean? That means our factors are x plus 30 and x minus 5. And you can verify by multiplying that those are the correct factors. And this equation has two solutions. One is negative 30 and the other one is positive 5. But In this problem, only the positive solution makes sense. So 5 miles per hour, we can summarize and say Jillian's run rate was 5 miles per hour. Okay, these word problems take practice, and even though they're sometimes seem kind of silly, they're still good for you to learn how to do, in my opinion. Okay, let's move on to the next problem. Hey, James can plant a garden in 8 hours, but if his daughter helps, the two of them can plant the garden in 6 hours. Find how long it would take James's daughter to plant the garden by herself. We refer to this kind of problem as a work problem. So a work problem has one task that is being completed in different situations. So if you have a work problem, the equations have the form rate times time equals 1. 1 represents the job that is being completed. And depending on the unit for time, if time is measured in hours, then the rate is the hourly rate. If time is measured in minutes, then the rate is the rate per minute. And 1 represents the job that they are completing. So rate times time equals 1 for work problems. In the first part of the first sentence, we're told that James can plant a garden in 8 hours. So for James's rate, I'm going to use capital R sub J to represent James's rate. And in the first part of the first sentence, we're told that in 8 hours, James can plant a garden. So James's rate times 8 hours equals 1. This equation represents that James can plant a garden in 8 hours. Okay, we're also told in this problem, if James's daughter helps, the two of them can plant the garden in 6 hours. Find how long it would take James's daughter to plant the garden by herself. Okay, so for the daughter's rate, I'll just use capital R sub D. And for the daughter's time, all just use capital T. We don't need to distinguish the daughter's time from James's time because we know what James's time is. It's 8 hours. So the daughter's time is T, represented in or measured in hours, T hours. Okay, so if the daughter works by herself, she works at her rate for T hours to plant 1 garden. Okay, then we're given information about the 2 of them working together. When they work together, they can plant the garden in 6 hours. So when they work together, we add the rates, James' rate plus the daughter's rate. This quantity multiplied by 6 equals 1. So when they work together, we have rate times time equals 1. Okay, so far we have 3 equations, each having the form rate times time equals 1. We have a rate times time equals 1 equation for James. We have a rate times time equals 1 equation for the daughter. And we also have rate times time equals 1 when they work together. We want to determine the value of T, capital T, which represents the amount of time it takes the daughter to plant the garden by herself. So since we want to know what T is, what we need is an equation whose only variable is T. So in our equation, we want the variable T, but we don't want to see R sub J or R sub D. So how do we get there? Well, we're going to solve each of the 3 equations for the rate. For James, James's rate times 8 hours equals 1. So what's his rate? How do we solve for James's rate? Divide both sides by 8. Yep. So James's rate is 1/8. We divided both sides by 8. So what this means in more detail is that James can plant 1/8 of the garden per hour. This is his hourly rate. Okay, what's the daughter's rate?
Over T.
Yeah, 1 over T. We divide both sides by T to find the daughter's rate. So the daughter's rate is represented by 1 over T hours. We don't know what T is yet. That's what we're trying to find. Okay, then in the equation for them working together, we want to solve for the sum of their rates. James's rate plus the daughter's rate. So on this one, we divide both sides by 6. So James's rate plus the daughter's rate is 1 divided by 6. So what does this mean? It means that when they work together, they can plant 1/6 of the garden per hour. When they work together, this is their hourly rate. Okay, the next equation that we write down will be the equation whose only variable is t. So in the bottom equation, we're going to replace James's rate with 1 over 8. And we're going to replace the daughter's rate with 1 over t. Okay, so we're going to get this equation, 1/8 plus 1 over t equals 1 over 6. This is James's rate plus the daughter's rate. When they work together, the rate is 1/6. Okay, well, it's hard enough to find the equation, but now we have to solve it. So just note that if you get the wrong equation, then, well, you'll get the wrong answer. So getting the learning how to set up the equation is pretty important. Okay, we see that t is in a denominator. So when we solve equations with rational expressions like this, we want to find the least common denominator, and then afterwards multiply every term on both sides of the equation by the least common denominator. Okay, so the denominators are 8, t, and 6. What's the least common multiple of 8, t, and 6? Uh, 24t. So 24 is a multiple of 8, 8 times 3. 24t is a multiple of t because 24 times t. 24 is a multiple of 6, 6 times 4. Okay, so now we multiply every term on both sides by the least common denominator. You can think of this as 24t over 1 if it helps. So 24t over 1 times 1/8 plus 24t over 1 times 1 over t equals 24t over 1 times 1/6. Okay, in this first product, we get a cancellation. 8 goes into 8 once and into 24 3 times. In the next product, the t's cancel, t divided by t. And on the right-hand side, 6 goes into 6 once and into 24 4 times. So what we end up with is 3t plus 24 equals 4t. And then subtract 3t from both sides, we get t equals 24. Okay, so our summary would be that James's daughter takes 24 hours to plant the garden. Okay, let's get started on the next one, number 4. Okay, this one says Jenna flew 1,080 miles in a jet, and then she drove 240 miles in a car. The jet traveled 300 miles per hour faster than the car, and the car ride was 1 hour longer than the jet ride, find the speed of the car. Okay, this is uniform motion, so rate times time equals distance. And we're supposed to find the car speed. So we can start by writing car speed and pick a variable like x. So x miles per hour is the car speed. And the other mode of transportation involved was a jet. So there's a jet speed. So how do we represent the jet speed if x represents the car speed in miles per hour?
300 plus X.
Yeah, 300 plus x miles per hour. That's given in the first part of the second sentence. The jet traveled 300 miles per hour faster than the car. What does it tell us about time driven and time for the car ride and time for the jet ride?
The car ride was an hour longer than the jet ride.
Yeah, the car ride was 1 hour longer than the jet ride. So we'll keep that in mind. And the distances are pretty clear. In the jet, Jenna flew 1,080 miles. And when she drove a car, she traveled 240 miles. So let's write down rate times time equals distance equation for the car, and then write down a rate times time equals distance for the jet. Okay, so the car's rate is x miles per hour. And for now, let's use t sub car to represent the amount of time it took Jenna to drive a distance of 240 miles. And for the jet, we'll write an equation of that form, rate times time equals distance. Okay, so the jet's rate, you can write it as 300 plus x or x plus 300. Either way is okay. I'll write it as the binomial x plus 300 multiplied by t sub jet, which represents the amount of time it took the jet to fly 1,080 miles. Okay, we're given that the car ride was 1 hour longer than the jet ride. So the amount of time it took the car to travel 240 miles is greater than the amount of time it took the jet to fly 1,080 miles, and it's greater by 1. Okay, so we want to know what the value of x is. That means we need an equation whose only variable is x. So we're going to use the two equations and the inequality to come up with that equation. So first, let's convert this inequality into an equation. So the amount of time it took the car to travel 240 miles is more than the amount of time it took the jet to travel 1,080 miles. So t sub car minus t sub jet equals 1. And then we're going to solve this equation up here for t sub car. If we divide both sides by x, we get t sub car equals 240 divided by x. And we'll solve the second equation for T sub jet. So T sub jet is 1080 divided by x plus 300. Okay, then in this equation, replace T sub car with 240 over x. We subtract T sub jet, which is 1080 over x plus 300, and this equals 1. So then the least common denominator is x times x plus 300. Okay, we're out of time. So finish this one on your own. Multiply every term on both sides of this equation by the least common denominator, and then solve that equation by factoring. Okay, that's all for today. Go ahead and sign in for attendance.